Okay, so before we start, a very good evening to all our audience. 各位同学大家晚上好。So today is our live session for question discussions on the quiz we had yesterday, and we will have the results announcement in a short while. So together with me is Dr. Chong, our president of Astronomical Society of Penang. And for information, the quiz questions you all had yesterday is set by both of us, which is me and Dr. Chong. So a simple self-introduction. I'm Lai, a committee member from Astronomical Society of Penang. 我是李宏俊，是槟城天文学会的会员然后 and then also I'm currently a PhD student in Penang University. So without wasting more time, let's look on some selected questions. So for the first hour, 1 hour and slightly more, we will have a question discussion, selected questions discussion, and after that we will have the result announcement. So while waiting the result announcement for the preparation of the results, we are currently going to discuss a bit on the questions. So the whole intention of this session is hopefully through the quiz you all can learn something, and not only winning or going into the final or winning or not, but hopefully you all learn something throughout this live session and throughout the quiz. So the first selected question is question 4. So these selected questions are actually a question that most of the students did not answer correctly. So for question number 4, so let's see on this. All right, so this is question number 4. So students might ask, during the quiz yesterday, they did not actually see all these photos. All right, so this illustration or this diagram is added so that we all can have a better explanation to you all. So this is a little bit about positional astronomy. That means based on the position of the terrestrial's body, and then we will experience or we will observe different phenomena. So first is transit. Transit is a phenomena where an object passes through a sun. For example, Mercury transit, Venus transit. So in Chinese we call it 凌日，也就是说，一个天体或者是一个卫星什么都好，就是穿越太阳穿过太阳的现象，所以叫凌第二个叫冲that means opposition. Opposition that means it is behind us. All right. In simple word, that means it is behind us. 也就是说，这个天体在我们地球的背面。也就是说，我们面向太阳是前方的话，背面的话就是冲我们晚上看到背面的就是冲。那么还有一个就是和 conjunction. Conjunction is simple. That means two objects goes very close together. So over here, we can see Venus is in front of Earth. So it is impossible for Venus to appear behind Earth. So among these four, Venus opposition is impossible to be observed. All right. 所以就是说，金星冲日的话，因为金星是在第二个轨道，那么我们是在第3，金星在第2，那金星是不可能绕到我们地球背面去的。也就是说，这个情况下，金星冲日是看不到的那么水星和火星的话，就是如果说这边是地球，这边是水星轨道的话，那么形成一条直线的话，那么当火星在这个位置，水星在这个位置，那么就会出现合的现象。That means Earth is over here, if Mercury is here, and when Mars is over here, then we can have the phenomena of conjunction. All right, so Dr. Chong would like to elaborate a little bit on using Bahasa Malaysia.
Yeah, so, okay. Jadi, a very good evening to all the student participants, parents, teachers, and astronomy enthusiasts. So this is our explanation of the results of the first round of the Penang State Astronomy Quiz Competition for primary school. It was held yesterday. And what Lai meant is that in the first round, we had 100 questions. There are two sections. Section A got question number 1 to question number 90. Question B is question 91 to 100. So question A, section 1, each question only got one answer. By question B, each question can have more than one answer. Okay. Jadi, selamat malam adik-adik, ibu bapa, cikgu-cikgu. dan peminat astronomi. Selamat datang ke penjelasan AstroCafe untuk pertandingan kuis astronomi untuk sekolah rendah peringkat negeri Pulau Pinang 2021. Jadi kami akan bincangkan itu soalan-soalan berkenaan dengan ujian kuis yang berlangsung semalam. Ini ialah bahagian A, ada pusingan pertama, bahagian A dan B. Bahagian A, soalan 1 ke soalan 90. Ialah tiap soalan ada satu jawapan objektif. Dan bahagian B, soalan 91 ke soalan 100, tiap-tiap soalan ada satu atau dua jawapan objektif. Alright, so Lai, you can continue. 大家好啊. Okay.
Okay. So next we go to question number 13. So Dr. Chong.
Now this one is a kind of picture thing. Is the pictures of the scientists are in the question. Gambar-gambar ahli astronomi ini adalah dalam dia. So you should know, those of you students have seen a lot of documentaries, should be able to recognize. So the question 13 is, who in the following is not a cosmologist? Remember, a cosmologist is a person that study the big question of the universe. Jadi siapa di sini gambar yang bukan ahli kosmologi? Seorang ahli kosmologi ialah kajian soalan besar macam letupan besar. The best example was Stephen Hawking. Of all the ones that is not is, there you are, number 2, the lady here, Professor Jocelyn Bell Burnham. She's actually a radio astronomer. Remember, the discoverer of the pulsar. She looked happy, By the way, she shouldn't look happy because she should have won the Nobel Prize, but they didn't give it to her, right? So the answer to question 13 is B, not a cosmologist, is Jocelyn Bell Burnham. The others, Michio Kaku, Stephen Hawking, Neil deGrasse Tyson, they actually have done a lot of work on cosmology. Yes. Next.
OK， 所以简单说就是这个 B 的 Jocelyn Bell Burnham 他不是这个宇宙学家啊，那么其他3位都是。那么接下来我们看下一题。So question 28 also question set by Dr. Chong.
Yeah, this is interesting. Ini adik-adik, tahu ke di sini soalannya adalah raja ini menunjukkan gelang-gelang Zuhal yang dirakam oleh kapal angkasa Cassini dari NASA. Setiap gelang utama terdiri daripada banyak gelang-gelang kecil. Secara keseluruhan, berapa banyakkan gelang kecil di sini yang orbit Zuhal? So you have the main rings. Like we know, see to a telescope, see the main rings are A and B and C and D and F and so on. For example, this big one is one whole ring, big main ring and so on. But from Cassini, we have seen that there are many tiny rings. And the tiny rings are called the ringlet. Dipanggil gelang kecil. Jadi soalannya adalah, how many ringlets are there? The correct answer is B, in the thousands. Beribu-ribu gelang kecil. That's it. Thousands of ringlets. B is the correct answer.
Okay, so just add on before we continue. So if you happen to have any questions, so feel free to type it in the comment section on this Facebook or our YouTube channel so that once we see, we can answer you all as soon as possible. All right, so yes, let's proceed to the next one. 好，我们看下一题。Okay, question 37. Question 37 is set by Dr. Chong as well.
Yeah. So this one is this. Given below are the names of famous optical telescope and the location. So here there are more than 4 telescopes, many. So basically, what is the question? It says like this, below. Of course, here 1, 2, 3, 4 all given. But then, which answer below is correct considering the size of the telescope in terms of decreasing diameters from the largest to the smallest of the primary mirror of the telescope. So there are 4 telescopes here. The correct answer should be, first one should be the largest aperture telescope. Second is the second largest, third largest, and fourth largest. The correct answer is D. Yang betul ialah D. D is, kita tahu teleskop terbesar bukan di Hawaii, bukan di USA, di Spanyol, Spanya. The biggest telescope is in a place in Spain. So it's a Gran Telescopio Canarias. I think the aperture of the primary mirror is more than 12 meters, The second largest one is number 3, Keck Telescope in Hawaii. Remember? Keck Telescope, lost already the picture. Keck Telescope were 2, Keck 1 and Keck 2, and each of them got aperture about 10 meters. Alright? The third one is number 4, which is South African Large Telescope SALT in Africa. So South Africa got the third largest optical telescope in the world, right? It's in near to the desert there. And then number four is our two Subaru telescope in Hawaii, which is about 8.2 aperture meters. So all these telescopes, no doubt, even four, the Subaru telescope is still very big, no? But the biggest is in Español, Spain, more than 12 meters aperture, right? So the correct answer is D.
Okay, so actually you all can compare over the aperture of this big telescope over here. So for example, this is over here we have compared to a tennis court and a basketball court. So for example, over here we have this 30-meter telescope in the Hawaii. All right, and then we have the Subaru telescope over here. So this is the size of a Subaru telescope. Okay, and then we have this in the Gran Telescopio Canarias in Spain. Okay, so this question is actually related to the previous question on question 36. 那其实跟前一题是一样的，差不多一样的。So the question asks, where is the world's largest optical telescope located? So the answer, the largest optical telescope is this one, the Gran Telescopio Canarias 加纳利大型望远镜就是在西班牙的。Okay, and surprisingly, looking at all the answer chosen, a lot of students choose Hawaii, USA. Right. So sorry to make this comment. Okay, that means not all the most advanced things or all the best things are in America.
Now you go back to the earlier picture with all the telescope picture there. Okay, now like put here earlier is true that they are building a 30-meter aperture telescope in Hawaii, but now there's a bigger one. The Europeans are building in South America, Chile. I think it's the 33-meter aperture telescope. So the largest telescope is only temporary. As time passes by, new telescope are built, bigger telescope are built, optical telescope. Okay, right, next one.
Okay, so many students choose A as well. I know you choose A maybe because of the FAST telescope, the largest telescope. It is the largest telescope. 这个 FAST 就是500米的那个天眼是世界上确实是最大的望远镜。但是我们审题很重要，就是这个题目光学望远镜 （Optical telescope）。That means the FAST is a 500-meter aperture radio telescope。那个是射电望远镜，这个是光学望远镜。就是说，你通过这个望远镜的话，你是可以看到东西的，用肉眼可以看到的。但是贵州的这个呢，它是射电望远镜。射电望远镜的话，就是你看不到的，就是你肉眼看不到的，它不是在可见光的范围内，它在可见光以内跟以外就是不在不同的范围内。So this question, the trick is over here 这就是陷阱
Jadi, Lai yang jelaskan. Ada ramai orang menjawab, dia jawab A ialah jawapan tak betul kerana dia ingin ialah teleskop radio fast di China. Tak betul. Inilah teleskop terbesar optik di dunia. Ialah di Spanyol lah. Bukan di China. China lah teleskop fast ialah teleskop radio. Canary Island ialah teleskop optik. Ini yang betul lah. B yang betul.
Okay. So next. So yeah. Just a reminder to all our students who are watching our Facebook Live. So these photos over here in the slides today are put in so that you all can have a clear picture and to help us in our explanation. So the question you received yesterday mostly don't have these pictures. All right, 就是说你们昨天的这个题目收到的题目做的题答的题呢是没有这些照片的。Okay. So, Dr. Chong, maybe you...
Ya, macam ni. Jadi di sini ada dua teleskop. Kiri adalah teleskop Dobsonian, kanan teleskop itu what you call optik lah. Okay.
Dr. Chong, maybe you tell them that these pictures are not appear in the question yesterday.
Jadi di sini dalam soalan dalam soalan online, gambar-gambar ini tak ada dalam itu form lah. Tapi ini yang live yang campur di sini untuk buat dia menjelaskan dia lah. Right. Jadi yang kiri ialah teleskop Dobsonian, yang teleskop kanan ialah teleskop German equatorial. Okay.
Okay. So over here you can see this is a Dobsonian telescope. So this is the main difference. First, this is counterweight. This part is missing. So counterweight, they don't have counterweight over here. So Dobsonian telescope, no counterweight. So number one is not. Number two, this is declination control knot. That means the control the declination, the knot is over here. All right. So over here you don't have knot. All right. You don't have knot. You have a small wheel. All right. So the knot is not a part of a Dobsonian telescope. Number 3, German equatorial mount. So this thing is a German equatorial mount. All right. It doesn't exist in the Dobsonian telescope over here. For Dobsonian telescope, it's relatively simple. You have the optical tube, which is the optics, and you have the base. This is the two main part. 就它这两个部分，一个底座跟一个光学的这个观望筒啊，就是这样。然后 another thing is tripod. So this is a tripod. The leg to support the mount and the telescope, the optical tube is the tripod. So over here there's a base for the Dobsonian telescope 啊，就是杜布森望远镜的话，它只有一个底座，它没有这个三脚架。So the answer is D, 1, 2, 3, 4. 这四个都没有啊，这四个都没有。
Okay, jadi adik sini antara berikut yang manakah bukan bahagian-bahagian teleskop Dobsonian. So teleskop Dobsonian di kiri, teleskop German equatorial di kanan. Jadi counterweight ialah itu pemberat. Tengok yang kanan itu dia ada counterweight, tapi di Dobsonian teleskop tak ada counterweight. Okay, how does it balance? It balance here on the mount here. Alright, for Dobsonian. Declination control, alright, di itu equatorial mount ada, itu right ascension control ada, tetapi dalam itu Dobsonian tak ada. Dobsonian dia guna dia guna altitude control and azimuth. Itu yang Dobsonian. Jadi dalam Dobsonian tak ada declination, tak ada right ascension. And di sini Dobsonian, tengok di sini apa itu? Now it's called alter azimuth mount. Inilah penunggang alter azimuth untuk Dobsonian. Bukan yang kanan. Kanan ialah German equatorial mount. Okay? Dan yang tengok Dobsonian dia ada satu plate saja. Satu plate, tak ada 3 kaki. Jadi semua bahagian di sini tak ada dalam teleskop Dobsonian. Jadi jawapan D yang betul lah.
Okay. Next, question 47. What is the ultimate fate of a star similar mass to the sun? So if a star which is similar mass to the sun, so we know our sun, all right, the image is placed wrongly over here, but then it's fine. All right, this is supposed to be in the previous slide. But then back to the questions, the ultimate fate of the sun, that means our sun will slowly, after many years, all right, after million or billion years, all right, our sun will become a red giant, will expand. And then after that, the sun dies. When the sun dies, it will become a white dwarf. But then the white dwarf is not the ultimate fate, all right? After white dwarf, it will slowly cools down, okay? 它就会慢慢冷却，成为 black dwarf， 就是黑矮星。就是说太阳，它现在是成年的太阳，成年太阳过后，它会成为什么？就是它老的时候，老年的太阳，就是它会成为红巨星啊 ，red supergiant。然后过后的时候，它会变成白矮星，就是太阳要死的时候，死了之后就会变成白矮星。那白矮星的时候，它的温度还是很高的，它会慢慢冷却。过了好多年之后，几万年之后，它就会变成这个黑矮星啊，就冷却下来之后就会变成黑矮星。
Okey, jadi soalannya lah, apakah takdir mutamat satu bintang dengan jisim yang serupa dengan matahari? Jawapannya betul ialah B, kerja hitam. Jadi usianya matahari sekarang ialah macam bintang macam matahari lah 4,5 bilion tahun. Bangkok 4,5 bilion tahun. Jadi masa depan matahari akan kembang menjadi red giant, raksasa merah. Alright? Dan ada sebahagiannya akan letup. Berarti yang bahagian yang paling letup mengecut menjadi kerdil putih, white dwarf. Tapi belum, ini bukan itu bukan hari kiamat untuk matahari tau. Selepas menjadi kerdil putih, dia akan hilang tenaga, hilang haba, suhu akan turun. Jadi putih, kerdil putih ke kerdil hitam kan. Jadi itu hari kiamat, satu bintang macam satu matahari adalah kerdil hitam. Jadi bila dia akan menjadi kerdil hitam? Bertrilion tahun depan lah. Trillions of years in future, only it can radiate its heat and become a black dwarf. Jadi jawapannya lah black dwarf. Bukan neutron star, bukan kerdil putih. Okay?
Okay, and also not black hole, okay? Because if you want to become a black hole, you need to be a few hundred times larger than our sun.
Yes.
OK， 就是你要比我们地球比我们这个太阳还要大几百倍，你才能变成一个黑洞。
Yeah.
Next, okay, imagine that the sun in the solar system suddenly turn into a black hole with the same solar mass. That means the mass doesn't change. So what would happen to the Earth? So this one actually related to the Newton's law of gravity. All right. So Newton's law of gravity, I understand that most of y'all did not learn about this yet. So over here, the Newton law of gravity 就是牛顿万有引力定律的话，是用这条公式来代表 G times m1, which is the mass of the first object, times m2, the mass of the second object, divided by the square of the distance. So in the questions, let's say our sun suddenly become a black hole. With the same mass, that means the mass does not change. 就它的质量，太阳的质量还是一样的。那么质量没变换的话，那么我们的距离当太阳一变成黑洞的时候，我们的距离也是一样的。那么在这种情况下，我们的引力就是基本上我们的 m1 就是太阳的质量没变化 ，m2 是地球的话，地球的质量也没变化。G is a constant， 所以 G 是一个常数，也是不会变化的。那么在同样的情况下，当太阳一变成黑洞的时候，这个距离也是不会变化的，也就是这个 D 也是保持。那么如果这每一项就是 M1、M2、D2 都是一个没有变化，就是它不是一个变量 ，that means M1、M2 and D square is a constant, it's not changing. So the gravitational force is the same. 就是说地球接受跟太阳之间的引力是一样的。So when the gravitational force is the same, then nothing will happen to the Earth. So our Earth will still remain in the orbit. All right, but not necessarily. In terms of orbit, nothing happened. But in terms of daytime and nighttime, in terms of optically, in terms of light, then we will experience difference. That means we will never see sunlight anymore if our sun turns into a black hole.
Jadi ini soalan je lah. Bayangkan bahawa matahari dalam sistem suria tiba-tiba berubah menjadi lorong hitam, black hole dengan jisim yang sama, satu jisim matahari. Apa yang akan terjadi pada bumi? Jawapan betul ialah tak ada apa-apa berlaku. Tidak ada apa-apa perubahan, orbit bumi tetap sama. Okey? Inilah. Jadi ini bermaksud, jadi kita tahu yang penting di soalan ialah secara teknikal ialah katakan ini ialah matahari. Alright? Inilah bumi. Yang pentinglah sekarang ialah matahari di sini, ini dipanggil curvature of space-time, kelingkungan ruang masa. Jika di sini kelingkungan ruang masa macam ni, matahari, dan di sini bumi. Jadi kelingkungan ruang masa di bumi ialah kerana bakal di sini. Dan tiba-tiba matahari menjadi black hole. Jadi dia menjadi black hole, kelingkungan masa di jarak bumi tak berubah. Because when the sun is in the center now, and this is the Earth, the curvature of space-time as sensed by the Earth at the current distance from the sun is so much. But now the sun becomes a black hole here. So will the Earth's curvature of space-time will change? No, the curvature of space-time at the Earth location will not change. So no change in the orbit of the Earth. Okay? Jadi bumi akan disedut serta-merta ke dalam hulu. Tak boleh. Sini ialah matahari, alright, black hole, alright, black hole. Dan di sini ialah bumi jauh tau. 150 juta kilometer. Tiba-tiba macam ni, tak boleh. Even then, it will take many days for the Earth to go to the sun. Many days. Even become a many, tak mungkin. Right? Dan di sini, bumi akan mengorbit lebih cepat. Tetapi, okey. Sekarang ialah matahari biasa. Ini bumi. Tiba-tiba dia menjadi black hole. Right? Black hole. Adakah itu bumi akan mengorbit lebih cepat? Tak. Dia tak ada perubahan itu laju bumi. Di bumi akan berpusing ke dalam sehingga sampai ke pusat lorong hitam. Jadi bumi bumi di sini akan pusing masuk. Tak mungkin. Jadi tak ada apa-apa yang perubahan. Yang perubahan yang berubah yang ialah yang Mr. Lai sebutlah. Tak ada matahari, tak ada cahaya lah. Gelap. Tak ada siang dan malam. Malam ialah malam lah, siang ialah malam. All over will be black lah. In that case lah. Itulah. Jadi soalan betul C. Tiada apa-apa perubahan, orbit bumi tetap sama.
Next. Okay, here comes the interesting part. Okay, section B, question 91. So starting from this section onwards, we have more than one answer. All right, we might have one answer, but we might also have more than one answer. So question number 91, sorry. So TikTok is a popular social media platform specially developed for video sharing. So I believe most of you all might watch a lot of TikTok short videos. So imagine that if smartphones and TikTok were invented 800 years ago, a Chinese astronomer Guo Shoujing would like to conduct a live session to share his astronomical equipment invention. So which of the following equipments might appears in his live session? So actually this question there's some hint for the answer as well. So 800 years ago in China is the Yuan dynasty, 就是800年前中国是元朝。那么元朝的时候有一个著名的天文学家叫郭守敬啊。那么郭守敬的话，就是他是一个天文学的发明家啊，他发明了很多天文仪器。So he invented a lot of these astronomical equipments. Okay, so the answer here is A, B, and C. So what is A? So if you realize A in Chinese we call it 高表. In English there's some direct translate called the height meter, but then this is not the correct the official translation. But in fact this 高表, okay, this 高表 is actually looks exactly the same of this Dengfeng observatory as shown in question 8. All right, remember the Dengfeng observatory. So this observatory is actually rebuilt by Guo Shoujing. Okay, so this is the 石龟, or this is the 石龟. So which the shadow of this observatory 就是这个观星台啊，这边有一个观星台，这边有个石龟，那这观星台的倒影就会给这个在石龟上，就会印在这个石龟上，就从这个石龟上我们可以测出在每一个同一个点，就是每天同一个点每天同一个点来测量的话，就能测出这个影子的长度，就能来测出这个季节。所以 A and this Dengfeng observatory is actually built based on A. B, okay, B in Chinese we call 仰仪仰仪. This equipment is used to observe the solar eclipse. So this is not the basin for you, not the basin for you to wash your face. So this over here, all right, on the globe, this is a half of the globe. There is some marking on the surfaces. 就是说，在这不是一个让你洗脸的面盆啊，这边它这个这个曲面这边呢是有刻度的啊，就是有刻很多数值，是用来观测日食 ，used to observe solar eclipse. Alright, and this is the simplified Amelia. 就是简仪啊，就是它其实最早期的时候是张衡发明这个水力的浑天仪，但是要用这个浑天仪的话就是太复杂了，那么郭守敬就把这个浑天仪把它给简化成为这个我们叫简仪。And then this is a seismograph 叫地动仪或者地震仪is used to detect earthquake. And this one is invented by Zhang Heng. The rest, the other three, are invented by Guo Shoujing.
Jadi adik, ini soalan saya baca. TikTok adalah platform media sosial yang popular yang dibangunkan khas untuk perkongsian video. Bayangkan jika telefon pintar dan TikTok dicipta 800 tahun yang lalu. Seorang ahli astronomi Cina, Guo Shoujing, ingin mengadakan sesi langsung untuk berkongsi mengenai penemuan satu peralatan astronomi. Model peralatan berikut yang manakah mungkin muncul dalam sesi langsung. Jadi ini soalannya lah, di sini ada 4 peralatan. Yang mana peralatan ini dicipta oleh Guo Shoujing. Guo Shoujing ialah ahli astronomi utara masa dinasti Yuan di China. Kita tahu dinasti Yuan ialah dinasti Mongol lah di China. Dengan maharaja masa itu ialah Kublai Khan tau. Jadi kita belajar astronomi, kita juga tahu sejarah Malaysia, sejarah lain-lain negara tahu. Jadi di sini 4 peralatan, 3 peralatan ini dan 1 yang kanan, yang mana dicipta oleh Guo Shoujing. Jadi jawab ialah yang A dan B dan C yang dia buat. Yang D ialah satu perkakas untuk mengesan earthquake, gempa bumi lah. Jadi ini tak betul. Yang betul ialah A, B, C. So A, B, C ialah jawapan penuh. Yang betul. Yeah.
Okay, so just to add on a bit, so the question looks very long, all right? It's like a long story, but the key of the question, that means when you answer the question during the quiz, actually the question itself is not very difficult. 其实题目本身不难，那么你注意审题的话，排除的话是可以把答案给排除掉的。就是 so if you read the question carefully, so basically is trying to ask you 就是他想问你的是什么，就是这边4样东西哪一个是郭守敬发明的？ That means among these 4, which one is invented by 郭守敬? Right. So the key point of the question is this. So which is invented by 郭守敬?
Yeah.
Right.
Okay. Correct. 92.
Next. Okay. Question 92, also by me. All right. Imagine if internet were introduced to the world 400 years ago. All right. 800 years ago, we have Guo Shoujing. So 400 years ago, we have Sir Isaac Newton. So if schools and universities were closed due to outbreak of a pandemic, Daniel wished to register online courses taught by Sir Isaac Newton. So which of the following courses he could register? So this is testing your whether you know the background of Isaac Newton or not. 那么这个主要就是考你们啊，看你们了不了解这个牛顿的背景啊。那么 we know that Newton is famous with the gravity, famous with the law of Newton's law of gravity, with the apple falling on his head, right? But then he know more than that, all right? 那么他知道的比我们认识他的还要多。那么 So the background of this question is trying to combine what we are experiencing now, and imagine that we combine the question what we are experiencing now to the past. 就是我们这些题目的设计呢，主要就是结合我们现在所经历的跟以前的情况，如果相结合起来的话，其实会发生很多很好玩的东西。所以同样的，就是这个我们的这个常识竞赛，这个天文学常识竞赛，我们也在做这样的东西。所以 Sir Isaac Newton. So Isaac Newton is a mathematician, all right? Is a physicist, is a mechanics. So based on this, all right, calculus itself is invented by Sir Isaac Newton. 就是微积分是由牛顿发明的。So if he invented this in the field of mathematics, then he have to be the one who teaching this. All right. So this is calculus confirmed. Algebra. So algebra is actually developed by Al-Khwarizmi, a Persian astronomer. Al-Khwarizmi 就是代数的话是 Al-Khwarizmi 发明了，所以代数的话其实跟这个微积分呢它是有差别的代数。那么代数可能你们现在小学也没学到，那么到你们上了中学的时候when you are going to secondary school in Form 1 or Form 2, you all might learn algebra. But for calculus, you'll learn it in higher level, maybe Form 4 or Form 5 in AdMax. You will have the chance to look at symbols like this. Sorry. Oops, sorry. Yeah. Oops. Where's mine? Okay.
No mind. Continue.
Wait. Something a bit lag. Sorry. Yeah. Okay. Yeah. So calculus, you will see some symbols like this. All right. Like a tau ge one. This is not the tau ge. All right, but this is for integration, and then you will see symbol like this. Okay. Or something like this. So this is what you learn in calculus. So this is something very important in mathematics, or even in physics. You might need a lot of this mathematics basic to solve a lot of physics problem. So and then classical mechanics. All right. So even for classical mechanics, the most famous one is the Newton three laws. All right. So the Newton first law is about inertia. Second law is F equals to ma, right? And then the third law is the reaction force. All right. So famous three laws in the Newton laws in classical mechanics is these three. Okay. And then modern physics. The father of modern physics is Galileo. All right. So eventually, the two most possible courses taught by Newton should be calculus and classical mechanics，就是微积分和经典力学，就是这两个。因为如果是现代物理的话，现代物理我们的现代物理之父是谁？就是伽利略啊，Galileo Galilei。伽利略是现代物理之父。那么 algebra 本身的话，应该是 Al-Khwarizmi。所以这两个最有可能这两个最有可能。So Dr. Chong?
Ya, jadi soalannya lah, bayangkan jika internet diperkenalkan di dunia 400 tahun yang lalu, sekiranya sekolah dan universiti ditutup kerana babak yang menular. Daniel seorang budak lah, ingin mendaftar dalam kursus atas talian yang diajar oleh Sir Isaac Newton. Wow. Manakah kursus berikut yang boleh didaftarkan? Jadi soalan ini ya, ABCD yang mana ialah bidang ini yang Sir Isaac Newton terkenal dalam? Jawapan yang A, calculus, B, D, classical mechanics. Kita tahu Isaac Newton ialah seorang pakar sains yang terkenal di dunia. Tahu. Di dunia ada dua orang yang paling terkenal. Satu Isaac Newton, satu ialah Albert Einstein lah, zaman moden lah. Jadi dia di sini, kita tahu Isaac Newton ialah ada dalam mekanik. Hukum 1 Newton, hukum 2 Newton, hukum 3 Newton. Okay, dia pun ada berkenaan dengan gravity. Tapi di sinilah hukum Newton. Alright? Classical mechanics dan calculus. Jadi Newton juga ialah pencipta calculus. He invented calculus. Alright? Masa itu dia tak guna nama calculus. Dia guna nama fluxion. F-L-U-X-I-O-N. Fluxion. Nama calculus. Tapi jika orang Jerman bantah. Orang Jerman katakan bukan Newton. Ialah Leibniz. Ahli matematik Jerman yang buat. Tapi kita tahu di dunia bahasa Inggeris, Newton yang mencipta kalkulus. Jadi lah yang tulis sini, yang simbol lambang-lambang ciri ialah untuk pengkamilan, integration. Yang kalau dia dy dx ialah untuk pembiasan, differentiation lah. Right? Jadi algebra yang lain sebut ialah dicipta oleh Al-Khwarizmi, ahli matematik Muslim. Right? Dan fisik moden dicipta oleh Max Planck. Right? Jadi yang jawapan betul ialah A dan D. Ialah yang betul. Jadi soalan ini ada dua jawapan, A dan D. Calculus dan mekanik klasik. Next one, Lai.
Next. Okay. I was a little bit surprised about this question. So, which of the following are not located in the outer solar system? 就是哪些天体不是位于这个外太阳系的？那么这题其实我非常吃惊，就是其实大部分的同学都没答对。All right, so actually I was shocked because most of the students don't get this question correct. So actually we can get the answer from this question itself. All right, so first is Deimos and Mars. Deimos is the satellite of Mars, right? It's the natural satellite of Mars. We know that Mars we have two moons, Phobos and Deimos. 就是火星有两个卫星一个叫火卫一，就是福波斯，然后火卫二就是德摩斯。So Phobos and Deimos, these are a pair. So if you select, you will either select A and D or B and C. But when I browse through the answer, a lot of students select A and B or C and D. They actually did not put the combination of A and D. This is something that surprised me a little bit. But back to the questions. All right. So how we divide the solar system? We divide the solar system into two parts. All right. We call it the inner solar system and the outer solar system. So the inner solar system is from Mercury to Mars. So when to Mars, the satellite of Mars, of course, is included in the inner solar system. And then between Mars and Jupiter, we have the asteroid belt over here. So after that, starting from Jupiter to the Oort cloud is considered as the outer solar system. So which of the following are located in the outer solar system? So outside, that means from Jupiter to Neptune. So eventually, Saturn is after Jupiter. 就是木星之后才是土星，所以土星就是在外太阳系。土星就是在外太阳系。那另外一个是 Io。Io is one of the moon of Jupiter. Jupiter have 4 big moons, right? We have Ganymede, we have Europa, we have Io, we have Callisto. 啊，就是木卫1、2、3、4啊，中文的话翻译相对简单啊，就是木星的卫星的话就是木卫1、木卫2、木卫3、木卫4啊，就1、2、3、4。那么 Io 的话就是 Io 是木卫1，所以 Jupiter starting from Jupiter is the outer solar system. So the moons of Jupiter eventually will be also part of the outer solar system. 所以这个木星的卫星的话，它自然也就是在外太阳系了啊。所以 B 跟 C 是一组的。如果你从答案上面来分析的话，来进行一些排除法的话 ，A 跟 D 是一组 ，B 跟 C 也是一组啊。所以选的话，如果你选 A 跟 D 的话，那么你就错。如果是选 B 跟 C 的话，那么就是一组，那么就其实很容易就猜一下，就是 you eventually if you group this A and D as a group, B and C as a group, then you have the percentage of 50% to get the correct answer. 就是你答对的几率就更大了。那么再来看哪一个比较远啊？火星跟土星的话，或者火星你不知道这个这个 Io 是什么的话，这个 if you don't know what is Io, then you know Saturn. So if you group A and D and B and C as a group, then you compare. You can actually compare. All right, which one is further? So the further one eventually will have a higher tendency to be at the outer solar system. So this is a little bit trick for you to how to get the correct answer from the options, right?
Jadi adik-adik, yang manakah antara berikut berada di bahagian sistem suria luar? Kita tahu bahawa itu sistem suria ada banyak bahagian. Dulu buku teks katakan ada sistem suria dalam, inner solar system, 4 planet, Mercury, Venus, Earth and Mars. Dipanggil planet-planet berbatu lah, terrestrial planet. Dan sistem suria luar, outer solar system, yang dipanggil raksasa gas, the gas giant lah. Jupiter, Saturn, Uranus, Neptune. Tapi dalam zaman moden ada bahagian sistem suria baru tau. Lebih jauh dari Neptune ada tali Kuiper. Lebih jauh lagi dari tali Kuiper ada awan Oort. Jadi di sini soalannya lah, yang manakah berada dalam sistem suria luar lah. Jadi mulai dari mesti cari lebih jauh, yang mana betul. Demo tak? Demo ialah bulan Mars. Inner solar system tak betul. Mars tak betul. Ayo ialah bulan, satu bulan terdekat Musitari. Betul lah. Ayo. Zuhal dalam outer solar system betul. Dan, jadi jawapan betul lah Ayo dan Zuhal.
Okay. So next. So no doubt. All right. Saturn is on the outer solar system. All right. Next. Okay, so this question is actually a big trick. All right, a very big trick. So which of the following astronomical event is or are suitable and safe to be observed directly using a telescope? 就是直接通过望远镜观测的啊。So the trick here is observe directly. Oops, sorry. All right. All right. The trick here is observe directly, 就是直接观测. So aurora, first aurora, we usually don't observe through a telescope, all right? Because aurora happens on the whole sky. So in the winter night, okay, you're lying on the snow or you lying at your balcony, all right, you with naked eye you can observe aurora. 就是你不需要任何仪器的协助哦，你就直接用肉眼就可以看见极光。Second, germinate meteor shower, because meteor shower is moving. Meteor is moving very fast. So if you want to track with your telescope, it's impossible because in a few seconds, in 1 second, shoop, no more. So if you want to observe meteor shower or meteor with a telescope, is impossible. With a binoculars maybe, but with a telescope, impossible. All right. And then Saturn opposition. All right. Back to the very first question that we discussed in this session. All right. Opposition, that means we can see Saturn using the telescope directly. We can observe Saturn. Okay. With a good telescope, no need to be a very big one. All right. Even with a small telescope, you can observe Saturn very clearly. 就是你通过一个不需要一个很大的望远镜，也不需要多贵的望远镜，用一个普通小的望远镜你就可以直接观测的话，你就可以看到 OK， 你可以看到土星的环啊，特别是土星冲日的时候，你可以看到土星的环。Another one is Venus transit. All right， 就是金星凌日。That means the Venus pass through the sun. All right. So remember, every time you buy a telescope， 就是每次你买望远镜的时候，它都会附上一个这样的警告的一个牌子。All right. So that you will always receive a warning, or even this sticker is stick on your telescope optical tube. All right, and it says, "Do not look at the sun through this telescope. Concentrated sunlight may cause serious eye injury. Children should use only with adult supervision." So this warning sign
opposition is opposite, not conjunction.
Opposite.
Opposition, not conjunction. Not close to the sun.
Yeah. Saturn
Okay.
is the correct one. Okay.
Saturn opposition, that means it's behind. That means at the night we observe, ma.
Yes.
Yeah,
Yes.
midnight lah. Midnight.
Yes. Yeah, midnight. All right. So back to this. All right. We will see a sticker sticking on your telescope. Okay, warning you that do not observe using the telescope directly. So the safe way, all right, the correct way to observe Venus transit is you need a solar filter. So over the question over here, it does not mention that with the aid of any other equipments. So that means observe directly. So without the equipment, without the solar filter, it's very dangerous to observe. So it's not safe. Okay, it must be suitable and safe. All right. So aurora is not suitable. Okay. Germinate meteor shower is not suitable. Okay. Venus transit is suitable but not safe. All right. It's very dangerous. It will hurt your eye. So the answer is only C, Saturn opposition. Okay. So remember, this is very important. All right. Never observe the sun with your telescope directly unless you have a solar filter. Okay. Dr. Chong?
Jadi adik-adik, soalan sebut antara peristiwa-peristiwa astronomi yang berikut, yang manakah adalah sesuai dan selamat untuk diperhatikan terus dengan menggunakan teleskop. Soalan pentinglah diperhatikan terus. So, Bai has underlined observe directly. Ini bermaksud guna mata kasar ialah perhatikan terus, ya. Guna teleskop pun boleh. Tapi tak ada macam penuras matahari, lain-lain tambahan. Right? So either you use the naked eye or even a telescope but no attachment. Jadi yang betul ialah Saturn opposition. Alright? You can use your naked eye to see Saturn or with the telescope with no filter. Tetapi aurora ialah besar tau di dunia. Dia seluas langit nampak aurora. Tak payah guna teleskop, mata kasar lah. Alright? Dan Gemini meteor shower, dia hujan meteor akan keluar dari mana-mana arah. Tak payah guna teleskop, guna mata kasar. Alright? Now, Venus transit ini, Zura akan bergerak depan matahari. Masa itu, kita mesti guna teleskop. Mengapa guna teleskop? Tak guna teleskop, cuma nampak matahari dengan mata kasar, tak nampak Venus. Kita mesti guna teleskop, tapi guna teleskop tanpa solar filter. Menjadi buta lah. Jadi kena ada solar filter. Jadi guna solar filter, dia tidak terus. You are not looking directly at the sun. You use solar filter. Jadi yang penting adalah posisi Zuhal macam ni. Kalikan di kanan ialah matahari, di tengah ialah bumi, di kanan ialah Zuhal. Masa itu kita boleh nampak Zuhal waktu malam, lebih kurang tengah malam. Itulah. Jadi di sini yang cara yang terus boleh perhatikan ialah Zuhal. Alright, opposite Zuhal.
就是再用中文提醒一下大家，就是这个警告非常重要。就是如果你们有望远镜的话，任何形式的望远镜，就是直接用望远镜来观测太阳是非常危险的就会伤害到你们的眼睛。所以同学们，如果说你们有望远镜的话，要直接观测太阳的话，记住了，就是要有一个滤镜，就是在你的望远镜前面要加一个滤镜才能观测就是 A 跟 B 都不合适，然后 D 不安全，所以只有 C 是答案。就是这样。Next, question 95. Okay, question 95 is also a trick. All right, and this question is designed this way. There are two information. All right, first is the question is like this: while Tom is walking by the side of a swimming pool, he realized that the pool appears to be shallower than it is, or shallower than its actual depth. So, which of the following equipment involved the optical phenomena observed by Tom? So, this phenomena Okay, the swimming pool looks shallower. It's actually the same as you put a coin in a cup, and then the coin appears shallower. So this is the phenomenon of refraction， 就是这是一个折射的现象。我们知道光它有几种反应，第一种是反射，就是你站在镜子前啊，你看到你自己，那种是反射；另外一种就是折射，就假设说你把一支笔放进一个水杯里边，那你发现到这个笔好像断了啊，这个就是折射。还有另外一种叫衍射啊，衍射的话就是 diffraction。So if a light diffract, then it will become you will see the diffraction fringe. Okay, so you all might know about reflection 就是折射跟反射，你们应该都非常熟悉。那么接下来我们就来看这个，从这边我们就知道，从第一个部分 ，OK, from the first part, we know, alright, this is talking about refraction. So from the second part, okay, which of the following equipment involve the optical phenomena observed by Tom? So equipment, okay, so we have 4 equipments over here. So 我们这里有4个仪器啊，4个光学仪器。那么使用到这个折射的原理的啊 ，involve the phenomena of refraction. So Gregorian telescope and Newtonian telescope is a reflection telescope, right? So this schematic diagram 就是这个示意图是一个牛顿望远镜 Newtonian telescope. All right, so we have a secondary mirror and a primary mirror. So it used the law of reflection. All right, so the light from very far 就很远的光啊，来到打到这个主镜啊 primary mirror, reflect 就反射到了这个啊 secondary mirror 啊，然后再一次反射，就是我们眼睛在这边观测。This is a Newtonian telescope. For a Gregorian telescope, it's the same, just that the observation point is over here. 就是说，如果是格里望远镜的话，就是我们就在这边凿开一个洞，然后我们眼睛在这边看，啊，这个就是格里望远镜。And then the third one, all right, B and D. So A and B is reflection, only reflection. For B is Galilean telescope, 就是伽利略望远镜 ，using the law of refraction. 就是用两个镜片就是可以观测，就像2个放大镜啊叠加在一起，就是这个最简单的就伽利略望远镜的一个原理。那还有一个就是 Smith-Cassegrain telescope 史密特卡斯德林望远镜。我们这个史密特卡斯德林望远镜呢，它另外一个名称叫 Cat dioptric telescope. Okay, so that means it combined 它是结合了反射和折射的原理。所以 over here there's a correcting plate. So over here it will undergo refraction and then reflection and then we observe over here. So first over here it actually involve refraction, and then it reflect in the primary mirror and then to the secondary mirror and then reflect to our eye. So it is combination of both reflection and refraction. All right, so the answer is B and D have the phenomena of refraction involved.
Okay. Jadi adik, ketika tuan berjalan di tepi kolam renang, dia menyedari bahawa kolam itu kehidupan lebih cetek daripada kedalaman yang sebenar. Antara peralatan berikut yang manakah melibatkan fenomena optik seperti yang diperhatikan oleh. Jadi adik di sini macam Mr. Rice jelaskan tadi, ada 2 jenis fenomena teleskop penting. Satulah reflection, pembiasan. Satu lagi ialah reflection, pantulan. Jadi di sini cari yang mana fenomena yang sama di sini. Tengok di sini ada satu siring dalam satu beaker, ada yang air, bukan? Jadi tengok, oh, mengapa cikgu ini itu cahaya optik bengkok dalam air kerana fenomena pembiasan reflection. Jadi yang mana di sini 4 teleskop ada fenomena pembiasan. Okey. Gregorian teleskop dia guna fenomena pantulan. Tak betul. Jadi Galilean teleskop betul. Galilean teleskop guna apa? Kantor lah. Depan ada kantor objektif, belakang ada kantor eyepiece. Jadi Galileo yang penting kan, dia orang pertama yang guna teleskop tengok ke langit. Dia bukan pencipta teleskop. Dia orang pertama guna teleskop tengok ke langit, tengok bulan, tengok galaksi. Right? Dan Newtonian teleskop tak betul kerana inilah Newtonian teleskop lah pantulan, bukan pembiasan. Dan Isaac Newton orang pertama yang mencipta teleskop pantulan tau. First inventor of the first type of reflecting telescope is Newton. Dan dia ialah Smith Cassegrain teleskop ada pantulan. Smith seorang pakar optik Jerman, Cassegrain seorang pakar optik Perancis. Jadi yang betul dua teleskop yang ada keseluruhan pembiasan refraction ialah B Galilean teleskop Galilean, B teleskop Smith Cassegrain.
Okay.
Yeah,
So next.
This is the last.
Yes. So suppose two stars are identical. That means there are two same stars, exactly the same. OK， 就有两个星星，如果是一样的，这两个恒星是一样的。假设这两个是恒星，假设我们有一个太阳，那么另外一个星星跟太阳一样，那么我们可以假设它另外一个太阳有两个太阳，就是这个意思。OK，but one is twice the distance away from Earth. That means， 假设说我们有一个太阳我们在地球，我们有一个太阳，那么还有另外一个跟太阳一样的星星还有一个跟太阳一样的星星。意思是说，我们地球在这边，太阳在这边然后还有另外一个跟太阳一样的星星，但是它的距离是跟地球的2倍，那么就是另外一个太阳是在这边That means if one is twice the distance, that means if this is Earth, then we have the sun. Let's say there's another star exactly the same. It's identical to the sun, but the distance is twice from Earth. That means, so this is one distance from Earth to sun, and then this is 2 times the distance. All right, 2 times the distance. Okay, they should be somewhere nearer over here. Somewhere over here, the star. Okay, so which of the following statement is true or are true? Alright, 就下面哪一项是对的 So I also believe that you all did not learn about this before, about luminosity and apparent brightness. Alright, so luminosity is the total amount of energy given off by a star each second. Okay, so it's basically the energy given off by a star is the luminosity. But apparent brightness is how bright the star that you can see. That means you see the star depends on how bright is it, how bright you see the star. Okay, so it's actually apparent brightness doesn't represent luminosity. Okay, apparent brightness does not represent luminosity. 也就是说，光度和你看和就是光度和视亮度是不一样的，就是你看到的它多亮跟它的光度，就是它一秒的时间散发出多少的能量，辐射多少能量，那个是不一样的不一样的。那么光度的话，就是它同样的星星光度是一样的，但是如果说亮度的话，或者是视亮度的话，就是你看到的亮度的话，那么就有其他的这个来影响了。就比如说这个距离，就是比较靠近的这个恒星的话，就看得比较亮。就打个比方，你看到木星的话，木星一方面它是最大的，但是它也是最亮，它也是晚上行星中最亮的。那么你会发现到，如果说你看木星跟月亮的话，可能月亮会更亮。为什么？因为月亮比较靠近，对吧？所以是这个视亮度就是apparent brightness bahasa Malaysia kata call this kecerahan ketara. It depends on how bright you see. It actually depends on the distance. All right. So luminosity is the same, but the distance affects the apparent brightness. So over here you see apparent brightness of further star is half of the closer, and then over here C it says apparent brightness of the closer star is double of the further star. So basically B and C means the same thing. All right. B 和 C 的意思是一样的。So B and C is a pair. A and D. All right. A and D it says the luminosity is the same. All right. So luminosity is the same over here. So the amount of energy, since 2 stars are identical, the amount of energy released per second should be the same. And then because of the apparent brightness, okay, is inversely proportional to the square of the distance. So since this is 2, so 2 times 2 you get 4. All right, so the apparent brightness of the closest star will be 4 times greater than the furthest star. It means the nearest star eventually it will be brighter, but how many times brighter? That means it's a square. So that means if the distance is twice, so the apparent brightness will be 4. Alright?
Okey, adik-adik, ini yang soalan terakhir. Saya dan Mr. Lai akan menjelaskan. Anggapkan terdapat dua bintang yang serupa. Bintang yang serupa bermaksud semua sifat dia samalah. Tetapi salah satu jaraknya adalah 2 kali lebih jauh dari bumi. Pernyataan berikut yang manakah adalah benar. Jadi di sini, ini yang satu soalan berkenaan dengan bidang astronomi dipanggil astrofisik. Jadi adik-adik, astronomi ada banyak sub-bidang. Ini dipanggil sub-bidang astrofisik yang sangat penting tau. Dia berkenaan dengan bidang macam fizik klasik ke fizik moden, dan fizik moden berkenaan dengan fizik kuantum dan relativity. Tapi inilah fizik klasik saja, right? Jadi kedua-dua bintang mempunyai luminosity yang sama. Luminosity di sini ialah macam kecerahan. Jadi sini misalnya ada buat satu formula, absolute brightness is L luminosity dibagi oleh 4 pi d square. Ini yang memberi satu penunjuk. Just a hint. Inverse square law of the distance. Alright, to answer question D. Alright. Jadi kedua-dua bintang mempunyai luminosity yang sama. Itu yang jawapan yang betul. Dan D, kecerahan ketara bintang yang lebih dekat adalah 4 kali lebih tertinggi dari bintang yang lebih. Nah, kecerahan ketara ialah apa yang kita tengok di bumi. This is the apparent brightness as seen from the earth. Whereas the absolute brightness is you go nearer to the star at a certain reference distance, that's the absolute brightness. But this is the apparent distance. What you see from the earth, right? Jadi yang betul ialah A dan D. B tak betul lah. Bintang yang lebih jauh mempunyai kecerahan setara separuh daripada bintang yang lebih dekat. No. Dan kecerahan ketara bintang yang lebih dekat adalah 2 kali bintang yang lebih. Tak betul. Right? Jadi sekarang saya dan Mr. Lai hantar itu pengumuman.
Wait. So there's one question I found from the comment section is just now got a student ask what is the diameter of this grand telescope? The diameter of this.
I don't know. Actually, but when it was built some years ago, straight away it broke the record. It's the largest optical telescope in the world, and of course, all large telescopes in the world are used segmented mirror principle. But on the top right-hand corner here, on the blue part, is made of thousands of smaller segments. Each small segment, no joke, no. Each small segment could be hexagon of 1 meter diameter, each segment. So this telescope is a big one. It's not on the mainland of this Spain. It's on the Canary Islands. It's off the coast of North Africa in the North Atlantic, but it belongs to Spain. Why? Because it's very high, air is very clear, no moisture, and the air is very clear throughout the year. That's it. So easily, but for the moment, the record is Grand Telescopial Canarias. In future, will be broken by the big telescope in Mauna Kea in Hawaii, America, and the big, extremely large telescope by the Europeans in Chile. All right?
It's a 10 meter, this one diameter 10 meter.
Yeah?
10 meter.
10 meter diameter.
Yeah.
Okay. So that's it about the question discussion we have today. So for information, we have 300 students registered, but then not all turn out, about 295 turn out. So I'll pass the result announcement back to Michael.
Okay. Jadi sekarang kami akan hantar itu pengumuman. Adik-adik semua sangat tertarik pengumuman itu keputusan pusingan pertama kuis astronomi untuk sekolah rendah Pulau Pinang kepada Mr. Michael Teo, ahli pertubuhan kami lah. Mr. Teo, to you.
Okay, can you hear me? Yeah.
Yes.
Okay. So, selamat petang, salam sejahtera murid-murid. Okay, 同学们大家晚上好。所以我相信saya rasa kebanyakan semua tengah tunggu saat-saat ini sudah tunggu 1 jam. Ada yang sudah tak sabar, bagi muka marah dekat Facebook juga ada. Sabar. Okay. So sekarang waktu yang sudah tunggu kan ，OK， 所以现在我相信很多同学都迫不及待的在等待这一刻 ，OK， 那么好，我们接下来呢就要公布我们今天第一圈的成绩。所以yang sekarang kita akan buat pengumuman pemenang untuk pusingan pertama first round. Okay, untuk pengetahuan murid-murid, untuk pusingan pertama ini kita akan tentukan pemenang pasukan. Pemenang pasukan ada 3 pemenang, okay, tempat pertama, kedua dan ketiga. Yang yang ketiga-tiga ini dia akan ambil jumlah markah daripada tiga ahli pasukan. Katakan ada 3 pelajar kan dalam satu pasukan, campur 3 sekali. Yang mana pasukan dapat markah tertinggi, akan menanglah 3 pasukan. 所以同学们，我们今天这个第1轮的比赛呢，我们是决定这个团体赛的这个优胜者，我们会选出3队，就是每队我们将队员的分数全部加总起来。最高分的3队就会就会有我们的这个优胜奖的第1名、第2名跟第3名。Okay, so are you ready? 准备好了吗，大家？ sudah siap kah? Okay, tempat ketiga. Jangan tutup mata. SK Batu Lancang, Team 2. Okay.
Wow.
Ahli pasukan Rafael Damian Mazhar bin Zulkifli, Divesh anak lelaki Gopinath Ryan Aiden Wilson. Okay. Jumlah markah total team score 145 daripada 330. Tahniah pasukan SK Batu Lancang Team 2. Okay, second place tempat kedua T. Erming SJKC Perempuan Cina Team 1. Okay, T. Erming SJKC Perempuan Cina. Ahli pasukan Chia Zhouwi, Dong Ji Ying, Cheong Ke Yun. Jumlah markah 154 daripada 330. Tahniah, congratulations, kongsi. Okay, sekarang ini dia, tunggu 1 jam untuk ini ya. Cikgu nak belanja makan kah? Okay, 全部等这一刻。最紧张的这一刻。我们公布第1名。1, 2, 3 SJKC 文凯 Team 1。文凯小学第1队。ahli pasukan Johannes Pun Yuehan, Chong Yuk Hong, Chong Jun Yi. Jumlah markah 154 daripada 330. Congratulations, tahniah, 恭喜文凯小学的第1队。Okay, so sekarang ada yang kecewa, ada yang gembira. Okay, jangan selain daripada kita ada umumkan ini pemenang pasukan, hari ini kita juga akan tentukan finalist, 20 orang peserta dengan markah tertinggi yang akan masuk ke pusingan kedua minggu depan. 除了我们这个团体赛的成绩呢，我们今天也会决定20名最高个人得分的同学会进入下个星期的第2圈的比赛，最终第2圈的比赛就决定个人奖项的。yang pusingan kedua minggu depan kita akan tentukan hadiah individu, bukan dari pasukan. Minggu ini pasukan, minggu depan individu. Sekarang kita akan umumkan 20 orang pelajar yang akan masuk ke pusingan kedua.
Jangan tutup mata.
Yang ke-20 Tan Ranger SJKC Perempuan Cina Team 2. Markah 49 daripada 110. Dan 19 ini dia tie ya. Dia
siap, Mr. Michael.
Dia tie dengan 18, so kita 12 saja. Teo Yuze SJKC Khao Kuang 50 markah. Shitata anak lelaki Wastu Pillai SJKT Mak Mandin Team 3 skor 50. 15 pun ini tie ya, dia 平手哈。Chong Yo Hong SJKC 文凯 Team 1 skor 51. Lim Peja SJKC Khao Kuang skor 51. 15 juga Ko Kai Ping SJKC Sidnya Team 2 skor 51. 14 Tivesh Nas anak lelaki Govind Nas SK Batu Lancang Team 2 skor 52. 11 Muhammad Khaim bin Ahmadi SK Sungai 2 Team 2 skor 53. 11 Seri juga Wong Zisan SJKC Hancang Team 1 skor 53. Seri juga Muhammad Faiz bin Anwar SK Kepala Patas Team 1 skor 53 juga. Nombor 9, Afif Danish bin Ahmad Fazli, SK bahan lepas Team 1, skor 54. Okay, ini sama juga, Thai juga. Okay, Chan Yen Cheong, SJKC Sinya, Team 3, skor 54. Okay, tempat keempat, Janani, anak perempuan di Afghanistan, SJKI Mamantin, Team 1, skor 55. Okey, seterusnya 3 orang pelajar yang markah paling tinggi. Ini dia. So temporarily lah, kalau kerana untuk penentuan pemenang pusingan kedua, kita akan campur markah dua-dua pusingan. Okay. Pusingan ini dengan pusingan kedua akan campur. So kan yang markah ini sangat penting juga. Kalau ini markah rendah sangat, nanti round tu buat tinggi pun tak bantu lah. So kena 2 round pun kena markah tinggi lah. Okay. So tempat ketiga yang markah paling ketiga tinggi, Ng Ji En, SJKC Chonghua, Seri ya, Janani dengan Ng Ji Ren. Alamak, okay. Bukan lah, sorry, tadi Peroka, saya sosial kerja. Kita tengok balik ni sampai 15, 10, sorry lah, ini sampai 6 sampai 9 saja. sorry silap kira. Ini 6 sampai 10. Okey. Okay, Ng Ji En, SJKC Chonghua, tim tu saya pun sangat cemas saya很紧张读错了，这里是第6名到第10名而已，不是第3名Okay, so Ng Ji En, markah 55. Rafael Daman Mirza bin Zulkifli, SK Batu Rancang tim tu 55. Yang inilah baru countdown 5. Okey, ini baru betul. Okay. Tempat keempat, Janani anak ini kelima. 5 dengan 4 seri sangat. Okay. Janani anak perempuan Pubalan, SJKT Pak Mandin. Okay. Markah 55. 4 seri juga. Tong Yuje, SJKC Chongchen. Skor 55. Ini baru nombor ketiga. Johannes Po Yue Han, SJKC Wen Kai Team 1. Skor 57. Okay, dan tempat kedua, Wei Yu He, SJKC Pacing Team 1, skor 58, 110. Okay. Yang last kali, markah tertinggi untuk hari ini, Chia Jowi, SJKC Perempuan Cina Team 1, markah 60. Ya, itu dia 20 pelajar dengan markah tertinggi yang akan lanjut ke pusingan kedua. So 以上就是我们今天20位个人分数最高的20位同学，他们将会进入到下个星期的第2圈的这个比赛，一决高低，决定谁是个人赛的冠军。我们机会有5个主要奖项跟5个安慰奖，所以下个星期20个人里面呢，有10个人会胜出，然后有10个人就可能要失落. Untuk pusingan kedua kita ada 20 pelajar, tapi kita ada 10 hadiah, 5 hadiah utama dan 5 hadiah saku hati. So tahniah sekali lagi untuk 20 pelajar ini. 再一次恭喜以上的这20位学生. Congratulations again.
Sekali lagi, Michael, tunjuk itu saudara 1/20 sekali. Maybe some of them didn't take it.
Okay, so for individual?
No, go to the team 1 and then go to the individual one. Just run.
Okay, so kita tunjuk sekali lagi. Tempat ketiga, SK Batu Rancang Team 2. Okay, tempat kedua, SJKC Perempuan Cina Team 1. Okay, tempat pertama berpasukan SJKC Wen Kai Team 1. Okay, 20 finalis, Tan Reza, Jeff Teo Yuze, Sitada, Naraki Alsupilai, Chong Yuk Hong, Lim Pei Jia, Ko Kai Ping, Tibesh Naf, Naraki Gobin Naf, Muhammad Khaim bin Ahmadi, Wong Zisan, Muhammad Faiz bin Anwar, Afif Danish bin Ahmad Fazli, Chan Yen Cheong, Janani anak perempuan di Afghanistan, Ng Ji En, Rafael Daman, Mirza bin Zulkifli, Janani anak perempuan Pubalan, Tong Yuje, Johannes Pun Yue Han, Wei Yu He, Chia Jowi. Ya, itu kita tengok sekali lagi pemenang-pemenang berpasukan hari ini dan 20 finalis yang akan lanjut ke pusingan kedua minggu depan ya.
I just add on Michael.
Ya.
Jadi ini rakaman ini adalah masuk dalam website, dalam YouTube channel Astronomy Pulau Penang. So if you want to see it later, you can look at it, archive one day later. you can see in the YouTube channel of the Astronomical Society of Penang. Okay.
So I pass back to you, Dr. Chong, in line.
Yes, I think we will announce the results in our
So
Facebook
later
page.
nanti kita pun akan post ni keputusan di halaman Facebook kita. So kalau kamu nak check balik pun boleh tengok kita pada Facebook page. So 等一下我们成绩也会公布在我们的这个面子书我们 Facebook 上面。所以如果你要检查回去我们刚才公布的成绩，你也可以到我们的这个 Facebook 上面去看一看啦。
Jadi kami akan berhubung dengan cikgu-cikgu yang itu semua 20 orang pemenang individu ini pusingan pertama, dan cikgu-cikgu akan bagi tahu kami memberitahu kami Pertubuhan Astronomi Pulau Pinang semua 20 orang pelajar. Jadi pusingan pertama akan dijalankan Sabtu depan 17 Julai mulai 9 pagi.
Okay, so yeah, congratulations to all winners. All right, you all did quite well. And we have a final round next week. 就是下周六我们会有我们的决赛。那么 just a little bit more. I give some. I think to help our students, I give a little bit of tips. Dr. Chong,
go ahead.
Allow me. So it's like this. We will have 10 objective questions and 5 subjective questions next week. So a little bit of hint is know your equipment, know the basic of astronomy, know the solar system, and I believe you can do well. So important thing is know how to use the equipment, including those maps, those like star chart, almanac, or whatever astronomy related maps. All right, and then we have for example, even our know your telescope. All right, all this, then you might able to do. And also, be aware of what happened recently. It helps. Okay.
So saya akan tambah lagi kepada what Mr. Rai sebut tadi ya. Jadi tajuk-tajuk yang berkenaan dalam pusingan pertama, jangan tengok ke buku teks saja. Dia tengok ke kuis-kuis antarabangsa sekarang untuk sekolah-sekolah rendah, semua tajuk terlibat. Basically is everything can be involved. Of course, pada perhitungan, no calculation, no formula lah. But basically all topics, right? And then macam Mr. Lai sebut tadi, itu berita-berita terkini astronomy, latest development mungkin akan ditanya. So basically is everything. So we don't want to make people that only remember facts only. You have to think, kena fikir punya tau. Soalan kena fikir. Okay? So it's like you want to make sure that when you can answer it well, you really will know what's astronomy. So any topic can be asked. Alright? Okay.
And just to elaborate a bit, tambah sikit for the berita the latest news, berita terkini. It doesn't mean that something that happened yesterday or last week or last month. Okay, it refers to 1 to 2 years or 2 to 3 years. All right, the range is 2 to 3 years. Not doesn't mean that okay, something happened yesterday. This one is not only that. All right, the range is slightly wider. Okay.
I can just add on, saya tambah lagi. Yalah, adik-adik kena balik belajar berkenaan dengan topik-topik fizik. Sama ada basic physics. Alright, I can give you like mechanic Newton, Newtonian mechanics and so on. And also you must understand some of a lot of those things in astronomy that is very basic. And of course, Mr. Lai sebut tadi berkenaan dengan amali, practical aspect. Jadi ini astronomy bukan baca, no, kena guna tangan. Yang kami selalu buat cerapan bintang, cerapan matahari, ada banyak aktiviti amali lah, lancar buat roket air. So even practical things can be involved, right? So basically, we are hope sure that we can cover all aspects of astronomy here, right? Jadi inilah 9 pagi Sabtu depan lah, kita mula pusingan kedua.
So we will get contact with their teachers for the final round lah. More information will be provided to the teachers lah.
Jadi ucapan tanya kepada semua pelajar, 20 pelajar lah pusingan kedua. Alright, terima kasih.
So the intention of this quiz is we hope you all learn something. 就是你们就是这整个环节下来，你们有学到一些东西，那个就是我们最主要的目的了啊。
Okay.
So congratulations, 恭喜。Okay. So I think that's it from us today. So wish those finalists all the best and have good performance next week.
Okay.
All right, see you all next week. Bye bye.
Okay. Okay.